Go to Yellowstone National Park today, and it's easy to get caught up in its beauty. You can see bison roaming the landscape, wolves calling in the night, even bears fishing for salmon. But when we think of Yellowstone's past, we usually picture something very different. We imagine the supervolcano at its center violently erupting and covering the surrounding states in ash. And while that is true, new research says that there's more to Yellowstone's story than just fire and brimstone, because life at Yellowstone not only survived the largest eruption in world history, it actually thrived afterwards. Hi, it's me, and this is my channel. Today, we are going beyond the eruption to explore how Yellowstone's wildlife really bounced back after one of Earth's most violent events. Yellowstone National Park is home to some of the most spectacular geothermal features on Earth, including the world's largest concentration of geysers, which make up about half of all known geyser occurrences worldwide. The park has waterfalls, hot springs, mud pots, fumaroles, which are like volcanic chimneys that emit gases, and of course, the Grand Prismatic Spring, which owes its rainbow colors to the bacteria living around its many vents. All of these features are powered by heat from the magma chamber beneath the park, which is so big that it's been dubbed the Yellowstone caldera. The thing is, this caldera didn't form from just any volcano. It formed from the supervolcano, which is one of the largest volcanoes in the world, and which sits right under Yellowstone. In fact, the supervolcano is so large that if it erupted tomorrow, it could blot out the sun and plunge the entire planet into an ice age. Fortunately, however, we have nothing to worry about because such an eruption is extremely unlikely. That's not because the volcano is dormant. It's actually quite active. There's so much activity, in fact, that the United States Geological Survey runs a 24/7 monitoring system just to keep track of it. Even so, it's been nearly 70 years since the last eruption, and it'll probably be another 50,000 before we need to worry about another major blast. Why? Because the supervolcano's last eruption happened in 3 phases between 630,000 and 640,000 years ago, and each phase was worse than the last. First came the lava. Flows covered the surrounding area in new rock. Then came the pyroclastic flows, which included surges of hot gas and ash moving at speeds up to 72 kilometers per hour. Finally, there was a debris avalanche, which is basically a giant landslide composed of pulverized rock and ash. This part of the eruption alone unleashed more than 2,400 cubic kilometers of material, which is about 5 times the volume of Mount St. Helens. But despite all that fire and brimstone, researchers are now suggesting that life at Yellowstone did not end with the eruption. Instead, it experienced a renaissance. To reach that conclusion, they studied sediments deposited during and after the eruption at 2 sites. One site called Massacre Tree, which is located on the northern edge of the supervolcano, had a buildup of ash so thick that it killed all organic matter in the area and created an anaerobic environment, meaning that oxygen was absent from the soil. The other site, called Buckleberry Ridge, was a few miles away, but sat on the edge of a lake, making it much less affected by the eruption. Here, scientists found fossils of freshwater fish called rhyococthids that were thriving prior to the eruption. And here's where things get interesting. At Massacre Tree, researchers discovered small mammal fossils in the layers of sediment right above the ones containing fish fossils. These fossils were small proto-whistlers, animals similar to modern shrews, which indicates that small mammals were able to move into the area soon after the fish died off and quickly diversified. Meanwhile, at Buckleberry Ridge, researchers found a total of 187 fish fossils, which were all found in the layers below the ash. So it seemed like the fish died off at the same time as the eruption. To determine when exactly all this happened, the team used something called argon-argon dating, which involves measuring the rate of decay of argon atoms in volcanic rocks. Using this method, researchers dated samples from both sites and found that the fish lived between 639,000 and 636,000 years ago, with the smaller mammals showing up right afterwards, around 637,000 years ago. Not only did this suggest that life rebounded quickly at Yellowstone, It also suggested that the rebound happened differently depending on the environment. At Massacre Tree, the proto-whistlers seemingly took advantage of the newly anaerobic conditions and were able to thrive in this previously unexploited habitat. This would explain why they diversified so quickly. On the other hand, at Buckleberry Ridge, there was no change in oxygen levels, and the smaller mammals showed up only after the fish disappeared. Maybe they simply moved in to take the fish's place in the food chain. Either way, though, this study shows that life at Yellowstone not only survived the second largest eruption in world history, it quickly recovered. But of course, Yellowstone's story isn't over. The supervolcano has had 3 full-fledged eruptions and many smaller ones. In fact, the magma chamber beneath the park is still moving and growing. So to better understand what might happen next, researchers are studying Yellowstone's most recent eruption. This eruption happened sometime between 12,000 and 14,000 years ago, which puts it firmly within the last ice age. During the Pleistocene epoch, woolly mammoths roamed North America. Neanderthals made their way into Europe. And somewhere in Africa, anatomically modern, humans were making cave paintings in Spain and building their first permanent settlements. So when researchers say that Yellowstone erupted sometime during the last ice age, they mean that it happened thousands of years before humans invented the wheel. Despite how recent this eruption is on the geologic timescale, it's been difficult to pin down the exact date. That's because the deposits from this eruption are incredibly thin compared to the older ones. They contain mostly rhyolitic ash instead of the basaltic kind, and they're largely undocumented outside of Yellowstone's borders. Scientists have found evidence of the eruption in the form of varbs, which are annual sediment deposits in lakes, but identifying them has been tricky since the eruption happened during the Ice Age. No one knows how long winter lasted back then. In the past, scientists assumed that the eruption occurred near the beginning of the Ice Age, around 12,000 years ago, because they thought that a hot eruption would disrupt the cooling process. But without hard evidence, that was just a guess. Recently, however, researchers found something new. They discovered a layer of ash at the bottom of a cave that contained pollen, charcoal, and bones of extinct Ice Age animals. By counting tree rings, scientists determined that the animals died in the year 12,775 BC. By dating the ash layer itself, they determined that the eruption happened in the year 12,900 BC. This eruption lasted for about a month and sent about 23 cubic kilometers of material into the air. Unlike the previous eruption, this one happened in 2 phases. First, there was a Plinian eruption, which produced towering ash clouds and pyroclastic flows. Then there was a phreatic eruption, which is triggered when magma comes into contact with surface water. This produced steam-driven explosions. It's still unclear what caused this eruption, but its timing offers some clues. Scientists know that magmas don't just spontaneously combust. Instead, they're pushed upward by forces deep inside the earth, and they grow steadily bigger as they gather more and more heat. It's possible that at some point during the Ice Age, the magma chamber began to rise faster than usual. As it pushed up, it melted parts of the ice sheet above it, creating a pocket of water that eventually reached the magma. When that happened, the magma rapidly expanded and violently erupted. Fortunately, this eruption didn't cause any mass extinctions. It may have contributed to the extinction of the North American megafauna, but that's debatable. And there's no evidence that it significantly impacted the global climate. Still, it must have been pretty scary to live through. Imagine you're one of the first humans to ever set foot in North America. You've traveled across the Bering Strait land bridge, and you're starting your new life in the new world. Just as you're settling in, the ground beneath you shakes. Ash fills the sky, and the familiar animals and plants around you begin to disappear. And that's if you survived the eruption in the first place. Today, that event is just a footnote in Yellowstone's history. But back then, it would have been a cataclysmic reset, an abrupt ending to one way of life, and the dawning of a new one. If you enjoyed learning about Yellowstone's eruptions, then you will love our newest show. This series takes you inside the biggest, baddest volcanoes on Earth. From Italy's Mount Vesuvius to Japan's Mount Unzen, each episode explores the cultural, historic and scientific significance of the world's most famous volcanoes. Plus, you'll get to hear amazing stories of survival from the people who have lived through these natural disasters. Thanks for watching. If you want to learn more about Yellowstone's supervolcano, check out this video.